Hello everyone, welcome to our first look at the QIDI X-Smart3 3D printer. And I've just recently received this. I've had it for about 2 weeks. And let's start with some stats. The bed is 180 by 180 with a print height of 170 millimeters. Has a magnetic double-sided bed that's good for 120C. Has a flow rate of 30 cubic millimeters per second maximum and 280 degrees Celsius temperature, an acceleration of 20,000 millimeters per second squared, and a maximum print speed of 500 millimeters per second. And this is a CoreXY printer. In addition, it's got a 4.3-inch touchscreen. We've also got a 350 watt power supply, which seems to be ample for the printer and its size. There's a carbon fiber gantry here that the print head sits on, and the extruder has a 9.5 to 1 gear ratio, which is quite powerful. The system includes auto bed leveling. It's mounted or supported from both sides, and also has a filament runout sensor, although right now that's not being used. And there's also a filament cutter as well that's built into the print head. It's got a Cortex A53 64-bit 1.5 gigahertz CPU, and the driver is a TMC 2209, nice and quiet. It's got 1 gig of DDR3 RAM, 8 gigs of eMMC storage, and Wi-Fi, no wireless Ethernet. And it also includes a USB interface as well to plug in any smart drives. The system runs Klipper. It includes the QIDI slicer and control panels, and these work on Windows, Mac, and Linux. It's primarily designed for PLA, but works great with ABS. I tested it. Also works with ASA, PETG, and TPU. And best of all, the printer comes fully assembled. So taking a look at some of this firsthand, here we can see the wires running through a cable chain along with the filament PTFE tube. And there we can see the rails made out of carbon fiber, which is really nice, which really helps in terms of the lightness. They claim the gantry weighs 600 grams. In addition, taking a look here at the print head, we can see the cooling, the fan, the insulation along, or the heat sock and the heater. But we've also got here in blue the bed probe as well. It's a non-contact bed probe, and we see here a really nice size blower as well to deal with cooling when you're trying to run 500 millimeters a second. In addition, looking at it a little closer, here you can see the really large extruder gears, which is atypical, or at least for many extruders these days, and that's really nice. In addition, you see the filament cutter here, the button for the filament cutter with the spring, and I find these really useful. I think it's really nice in terms of when you're trying to change filament, instead of trying to pull a partially melted filament through, which tends to get jammed in the print head, simply do a cut. And then when you unload the filament, any filament that has been melted stays in the print head. And so as you feed new filament in, it'll push that old filament out. I think this is a really good and useful feature. Looking at the bed rails and the screws for the bed, for a printer this size, these are really oversized, and the bearings and the rails themselves look like they're of extremely good quality, really nice and thick as well. And in addition, that screw is also, in terms of diameter, is big. And so ideally, this leads to better quality prints. Another really nice touch here is the bed has bed stops. And so they're all the way in the back. And whenever you insert the bed plate or the print plate, it simply sits in to those bed stops all the way in the rear, eliminating all the guesswork and the adjustments that you normally make by hand, trying to make sure the bed is seated in the right place. This is really nice. And on top of that, this isn't the standard magnetic sticker. It feels like a metal plate that's bolted down that has magnets attached to it as well, again, for good prints. Of course, when receiving your X-Smart3, you get much more than just the printer itself. So some of the items, of course, the quick start guide, It's really short and sweet, helps you get up and running really quickly. It also comes with a special paper plastic to help in terms of the bed leveling. It comes with a 16 gig USB drive, which includes the software. You get your bed scraper, which works well, by the way, a screwdriver, really nice actually. And in addition to the screwdriver, you get a wrench, a set of Allen wrench keys, and all the sizes needed for the printer. Some additional screws and replacement parts, which I didn't need any of. It includes an additional 0.4 millimeter nozzle, a replacement nozzle. It also includes the tool to clean a nozzle in case it gets jammed. It also comes with half a kilo of PLA of QIDI brand filament, which is great when you get a printer for the first time. So now that it's all unpacked, let's set this up. Once you plug in the printer, it'll take a little while to go through its boot up sequence. And then you'll need to select the language. And here it reminds you to cut off the 2 tie wraps that have secured the gantry. Obviously, we need to make sure we do that before we attempt to do anything. And then there are these shipping screws for the base for the platform that need to be unlocked. And once that's complete, we go ahead and step forward through the instructions. It's warning us here that the platform is about to be moved. And if we take a look down here real quick, we hit the button and the print bed moves up. And then here it's instructing us to remove the shipping blocks that were bolted down with the bed previously. And since we've already removed the screws, it's just a simple matter of quite literally just picking these up and taking them out. From there, the instructions step you through setting up a Z offset and simply using the supplied piece of plastic stock or shim as a spacer and following the directions. And simply, if any of you've done the paper test, this is the exact same thing where you're looking until you just start to feel some of the resistance on the card. And then once you do, that will be set as your Z offset. From there, after hitting next, it goes into input shaper mode to do resonance testing for X and Y. Again, using the standard Klipper feature set to do so. I'm going to speed this up probably even faster than the previous parts of the video. There just isn't a whole heck of a lot to see during resonance testing. And from there, it'll instruct you to load the filament. This is at the back of the printer. You can see I already mounted the filament holder here on the rear. It simply pops right in, slides right in. I'm going to use the spool that came with the QIDI printer. And then from there, it will allow us to start heating up the printer nozzle so we can complete the loading of the filament to the point where it can actually eject from the nozzle. And then once you've hit the correct temperature, it'll ask you to extract some of the filament, which I did. And then at that point, your startup tutorial is complete and you're back on the home screen and the printer is ready to go. From there, you'll probably want to take one more step and hook it up to Wi-Fi since it is Wi-Fi capable. And once you've done that, you'll be able to connect to it directly. So now we need to install the slicing and control software for the printer. The software you need comes on the little USB drive that they gave you. However, odds are it's probably a little bit out of date. And so here I've gone to the website. You can see there's actually firmware updates, which I need to install. And if you simply follow through, you can see here on the Google Drive where that's available to install. However, I'm not going to do that now. I'm going to focus on the slicer software itself. And so if we click on the option for the QIDI Print slicer, it takes us to the QIDI Print page. I'm going to go to the Google Drive location. And as you can see, it's available for Linux, Mac, and Windows. Um, if it's Windows, simply download this, run the installer. It's the same thing for the Mac. For Linux, you download the file and then you have to change the rights to make it executable. But once you do that, it should all run just fine for you. Once you've downloaded and installed the software and you have it running, here I've got the slicer running and I've loaded a Benchy. This looks like a customized variation of Cura. And so if you're familiar with Cura, pretty much everything should work as you can expect. It comes all preloaded. You've got PLA and ABS supported here, which is really nice and already custom set up and configured for the printer. In addition, you've got the different settings that you would expect normally for fine, medium quality, quick, and so on. You can also go in here and change it from basic view to advanced to expert view, depending on which and how many options you want to see here. And this works quite well. Once you're done, you can hit slice. It gives you the opportunity to check over things once quickly. And once that's done, again, just like in Cura, you can go through and run a preview. And in addition to the preview, once it's done, you can send it to the printer via Wi-Fi, which is really nice, so you don't have to use that drive. In addition, you have the control panel option here, and once you select that, this control panel pops up. You can select any of your printers, but in this case, I only have the QIDI printer. Here I've connected, and you can see here on the right-hand side under File, it's showing me any of the previous files that I've sent that are stored currently on the printer. So there's a file management utility for the storage within the printer itself. And again, these represent the jobs that I sent over using the slicer. And so you can go through, select these, delete these, upload additional files, download, whatever it is you need to do. Under communications, here we've got the control panel where you've got the options to jog the print head and the bed. You're able to go in and set extruder temperatures, speeds, fans, what have you. And then here it also shows you a temperature plot that it keeps track of temperatures while the printer was running. It's a nice utility and it's accessible within Cura. So how does it print? Turns out both really well and really fast. In an effort to get a better view of these prints, I went outside, outdoors, into the sunlight. Hopefully this works. So here's Benchy. Um, and this was printed at 300 millimeters per second and 10,000 acceleration. And this took about 30 minutes to print. It looks good. It looks real good, actually. Um, Everything pretty much looks as it should. I'm sure with a little bit of additional tuning, might be able to do just slightly better. But this is quite good because this is how it came from the factory. I did not adjust or tune a thing. And of course, we need to compare that with a 15-minute Benchy, which was 500 millimeters per second with 20,000 acceleration. And you see a little bit of ringing, um, and there are a few areas where it had a little bit of trouble, like right here at this portal. And if you look real closely, there are a few issues a little bit with the column supporting up the supporting the roof. But again, in general, I think with a little extra tuning, this could do better. And again, this is as the printer came out of the factory. What's surprising is just how close these actually do look to each other. Again, really fast, good quality prints. In an attempt to test bridging, um, for whatever reason, I found this spider, which I thought was really kind of cool. And if you take a look, it prints this base, and then in midair, it prints the spider web, which it had no trouble doing straight out of the box. And then on top of that, it prints a spider with its 8 legs and everything else. And again, this is looking really quite good. This was at 300 millimeters per second, 10,000 acceleration. And again, this is as it came out of the box. I did no tuning whatsoever. Again, I think that looks really quite good. And then we have the third print. I printed this rocket in vase mode. It's incredibly light. This weighs almost nothing. It printed from bottom to top completely in vase mode. And again, 300 millimeters per second, 10,000 acceleration. It I'd be hard pressed to get any printer I've got to do it this well. There's a little bit of a seam there, but that's to be expected. But in general, this looks really good. And again, this is straight out of the box. It was able to do this, which is really quite impressive. And then just for kicks, going back to that Benchy indoors, this was the one at 300 millimeters per second, 10,000 acceleration. Again, this is really looking quite good. The lighting's a little different, but there was no tuning, no adjustments made whatsoever. It's as it came out of the box. And I mean, there might be some minor adjustments to do here, but this looks really quite good. So now, my final thoughts. So if there are some possible negatives here, and I'm, stretching it, I wonder a little bit about the carbon fiber rails and the life of them and the fact that they're not replaceable, which gets me to worry just a little bit about cost of repairs. Also, the nozzle itself, it seems to be a slightly different size. It looks like it would work in my Rapido. For positives, the printer comes with a 1-year warranty provided by the manufacturer, which is fantastic. This is the fastest printer I've ever seen and that I own. It's great. And then the size, this 180 millimeter size is turning out to be fantastic. Um, it's becoming my go-to printer because it's just so quick and easy to get up and running. It always seems to work. And again, 90% or more of my prints will actually fit within the bed that's there. And so far, that extruder has been rock solid. It's super strong. It never skips a step. It just keeps going. It's been great. In addition, the hardware, as in the CPU, memory, and everything else, is powerful enough where it seems like it'll readily accept and be able to accept future software enhancements as well. In addition, there's no assembly required. Just take it out of the box, eliminate the packing materials, plug it in, and it's ready to go. I've never had a printer that easy to set up or configure. Which then gets to great prints straight out of the box. No tuning required. So the current price for the X-Smart3 is $479. That gets you a CoreXY printer, PEI bed sheet, magnetic, automatic bed leveling as well, too, with speeds of 20,000 acceleration and 500 millimeters per second print speeds. And this is all in an enclosed printer, which is great for filaments like ABS, where you really need that enclosure. I'm sure some of you will ask, how does this compare to the Bambu Lab X1 Carbon? And my answer is, I don't think it does. The price difference between the two are just vast. In terms of $479, you're getting quite a lot here, quite a printer. I think another comparison might be the Bambu Lab P1P, but that's also significantly more money. And although it is a CoreXY 3D printer, it's not enclosed. For me, for the price, this is a really nice printer. And if you are aware of any others that you think can compete to this price, please let me know in the comments below. If you're looking for a really fast, fully enclosed, full-featured 3D printer that's ready to go out of the box for $479, this is a great printer. I recommend it, and thank you for watching.